block slides down a frictionless incline from rest as shown in figure 2.62. The incline has an elevation angle of phi equals 35 degrees. After the block slides down a distance of d equals 25 meters along the incline, how fast is the block moving? So the first thing you should do when you're reading this problem is, even if the figure is drawn right, you should redraw the figure just to get an idea of what's exactly happening. So I'm going to redraw the figure. So here is our incline. Here's our angle phi. Here is our block. Now there are several forces acting on the block, so we're asking. So this block travels a distance of d. Phi is given by 35 degrees. Is it 35? Yeah, it's 35 degrees. Now, we can actually do a free body diagram, but we have to just worry about what forces are acting on the object to cause the system to actually gain kinetic energy. So we have two forces acting on the system. A free body diagram would tell us that there's a normal force and there's a force of gravity. So the normal force, right, would be Fn. Force of gravity pulling down would be Fg. So if you look carefully, the normal force is going to be perpendicular to the displacement as it's traveling. It's perpendicular. So this is going to be perpendicular. Because it's perpendicular, right, the normal force is not going to be able to do any work. If this was not a frictionless surface, if there was friction on the surface, the normal force would contribute to a resistive force, right, a frictional force going backwards, and then we'd have to take that into account. But we're told that the surface the incline is frictionless. Because it's frictionless, right, we only have to worry about force of gravity acting on the object. So the normal force doesn't contribute any energy to the system. So there's no work done by the normal force. So force of gravity is completely responsible for sliding the object. So the force of gravity, so we could say the work done is going to be equal to the force of gravity dotted with the displacement vector. And that's going to be equal to mv final squared, the change in the kinetic energy of the system. So we have a dot product to take care of. So we can have two ways of solving the dot product, but I'll just take it the easy way, which is basically find the angle between FG and D. So if you look carefully, so I'm going to redraw this diagram over here, I guess. Let me do it over here. Is it on the screen? Yeah, it should still be on the screen. So we're told that the force of gravity is acting down. Our displacement vector is along the incline D. We're told that the angle is phi. So if you look at parallel lines, so this line and this line is parallel, this angle is phi. So this angle, the internal angle theta, must be 90 degrees minus phi. Okay, so we can write this quickly as just that it's mg, mg, force of gravity. I'll put the actual notation down. The dot product is cosine of the theta of the angle between them, which in this case happens to be a force of gravity times d times cosine of theta mg d cosine of 90 degrees minus phi. And that's equal to 1/2 mv final squared. The initial speed is actually 0 because it starts off from rest, so we don't have to worry about that. And what we're trying to solve is this for this variable, m. So if you look carefully, the m's drop away in the equation, and we can move the 2 over to here, so we can say that v final squared is equal to 2gd times the cosine of 90 degrees minus phi. And so v final must be equal to the square root of 2gd times the cosine of 90 degrees minus phi. And there's enough space, yeah, there's enough space over here, so which is equal to the square root of 2 times 9.8. Oops. The displacement, the distance traveled is 25. We're all in standard units, so we don't have to waste time putting units down because the minute we're using kilogram meters a second, we don't want to waste time putting units down because we know what everything is. So we're taking the cosine of 90 degrees minus, and the angle is 35 degrees. And done. So you should be able to do this calculation in a single step in your calculator. You should be able to enter this equation directly into your calculator without. So I'm going to put down parentheses 2 multiplied by 9.8 multiplied by 25 multiplied by parentheses 90 minus 35 close parentheses cosine close parentheses and then square root, which is shift this calculator. So I get 16.76 meters, but we're going to round it up to 17 meters per second. So it's 16.76, which is rounded up to 17 with those two significant digits in the calculation. Anyway.